In this video, I'd like to show an example of integrating rational fractions by making partial fractions. This method uses partial fractions, so you need to know two formulas to set up partial fractions. If the denominator is a linear function, then the numerator should be a constant. If the denominator has quadratic factors, then we need a linear function on the numerator. If you take a look at the integrand of the question, it seems a relatively complicated fraction. If we can split it into simpler fractions, then we may be able to integrate them easily. Making use of partial fractions to get the simpler fractions. First, we need to have factored form of the denominator to make partial fractions, as we need to split the fractions by separating the factors. Taking the common factor x squared out to get x squared times x plus 1 for the denominator. We should consider x squared as x is repeated. Now separate the fraction into the partial fractions using undetermined coefficient a, b, c, and so on. Since the factor x of the denominator is linear, we use unknown constant a for the numerator. For the second term, x, which is linear, is repeated, so we use another constant b for the numerator. For the last term, still we have a linear function x plus 1 as the denominator. We use a different constant c for that. Next, we make a basic equation to solve for unknown a, b, and c values. To do so, we take the common denominator as x squared bracket x plus 1 for all terms. Once we took the common denominator, then multiplying each term by the common denominator to get the basic equation. Basically, all numerators are called the basic equation, which should be used for solving a, b, and c values. We have now the basic equation, so let's solve for unknown values. I use a substitution method to solve them in this case. Make one factor be 0 to eliminate one variable, substituting x equals 0 into the basic equation to get b equals 1. Make another factor be 0 to get x equals minus 1, substituting x equals negative 1 into the basic equation to get c equals 1. As there is no other possible x values which make a factor be 0, we choose arbitrary number x equals 1. Substituting x equals 1 into the basic equation to get 1 equals 2a plus 2b plus c. Since we already found the values of b and c, substituting those values to get a equals negative 1. Now we have solved for a, b, and c, so rewrite the integrand using those partial fractions. Substituting those values into the partial fractions to get the integral of minus 1 over x dx plus the integral of 1 over x squared dx plus the integral of 1 over x plus 1 dx. Finally, we need to evaluate each integral to get the solution. Let's change the expression of the second integral to evaluate it easier. For the first integral, we need to use the natural log formula with u equals x and du equals dx. No adjustment necessary here, so we can get the negative natural log of x. Place the absolute value symbol around x, since log can take only positive values. For the second integral, Since this has the power of negative 2, we need to use the power function formula. Using the formula with u equal x and n equal negative 2 and integrating to get x to the negative 1 over negative 1. For the last integral, we use the same formula as the first one, letting u equal x plus 1 and du equal dx to get natural log of x plus 1 plus c. Do not forget to use the absolute value symbol around x plus 1 and add the arbitrary constant c at the end. Finally, simplifying the two terms using the property of logarithm and changing the form of the second term to get the solution. This method allows us to change complicated fractions to simpler pieces of fractions, which are called partial fractions, so that we can integrate each fraction easily. If you like this video, please subscribe for more videos. Thank you for watching. See you next time.